In this lesson, we are going to determine if two variables vary directly or inversely, and what that even means. When variables vary directly, they increase together or decrease together. An easy example to understand would be a summer job and the money you earn. So let's say that you get paid $10 per hour. The money earned in your paycheck, we would say, varies directly with the hours you work, because you would take 10 times the number of hours to get the amount in your paycheck. So we would say P varies directly with H. Whereas inverse variation would be where one variable goes up, the other will go down. An easy example to understand would be speed. Speed varies inversely with time when the distance you travel is constant. So let's say you've got to go 100 miles to get somewhere. Well, you would take your speed times the time. So let's say that you're going 50 miles an hour. It would take you 2 hours to drive 100 miles, 50 times 2. Whereas if you drop your speed, let's say you go 25 miles an hour, you're driving much slower, it's going to take you 4 hours to go 100 miles. Whereas, let's say you go even slower, you drop to 20 miles an hour, it's going to take you 5 hours to go 100 miles. So what's happening? As speed goes down, time goes up. So one variable drops while the other increases. So let's look at direct variation now in a more formal way. In general, the equation for direct variation is y equals kx, where y and x are your variables. We would say this as y varies directly as x. You'll also see it written as y varies directly with x. So as we said before, this was like the summer job example. As x increases, y increases. It would also be vice versa, where x goes down, y also goes down. They move in the same direction. So k is just a number. We call it a constant. If we had to solve for k, you would, if you look at this example right here, you would divide both sides by x, and that would give me k equals y over x. So if you take y divided by x, we get the k value. And what does this represent? Well, hopefully you recognize y equals kx would be a line. So it is our ratio or our slope of the line. Okay, so in my example, the summer job, I said you got paid $10 per hour. You're looking for that ratio, that 10 per hour. So let's actually graph one now. Here's an example, y equals 2x. This would be like where you get paid pathetic amount, $2 an hour. So k is 2. So let's just pick some points to see what this looks like. So my independent variable, I'm just going to pick a few numbers, plug it in. -1 times 2 is -2, 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, and I'm going to graph these. -1, -2, 0, 0, 1, 2, and 2, 4. And then I'll connect that with a straight line. Now let's do a little flashback to Algebra 1. Notice that this goes through the origin. Well, it's always going to go through the origin because think about slope-intercept form, y equals mx plus b. There is no plus b when it's direct variation, or we could say that b is 0. So the y-intercept and also the x-intercept will always be 0. It has to go through the origin if it is direct variation. If it goes through anywhere else, it is not an example of direct variation. Another way that you'll see direct variation represented is you'll be told that it's a proportional relationship. That means you can use proportions to solve it. Okay. Now let's talk more formally about inverse variation. So inverse variation is in this form y equals k divided by x. You will see this written as y varies inversely as x, and we say as x increases, y decreases. If I had to solve for just my constant, still known as my constant of variation, we use a k here. If you look right here, how do I get k by itself? Well, I would multiply both sides by x, and I would get k equals x times y. So if I multiply them together, that's like my speed example, 50 miles per hour times 2 gives me 100 miles. I multiply them together. What does this represent? Well, this is a product, okay? So if I multiply together to get my constant, it's going to be inverse variation. Here, let's do an example now. I'm going to pick some values, and I'm going to be smart about them since I need to do 2 divided by. I'm going to work out some things that work out nicely. I'm going to do -4. So 2 over -4 reduces to -1/2. I'll try -1. Plug in -1. That's going to be -2. I'm going to plug in 1. 2 divided by 1 is 2. And I'm going to plug in 2. 2 divided by 2 is 1. All right, so I'm going to plot these points. -4, 1/2. So as I plot these points, I'm going to show you the shape that happens here. So what happens is it ends up being in the first and third quadrant, and I get this curve that gets really close to both the x and the y-axis, but it never ever touches. Looks like this. And there's some vocabulary here, which you've probably not heard before. It says, what will always be the asymptote? What this means is I have the x-axis and the y-axis here. It will never, ever, ever touch them. So our asymptotes are at the line x equals 0. That would be my vertical line, and at the line y equals 0. Our graph will never touch those. Okay. We're just going to look at some real-life examples, and you're going to tell me if this scenario describes inverse or direct variation. So the number of dollars you make varies how with the number of hours you worked. Well, we kind of talked about this already, but I think, okay, so number of hours, I just put an arrow going up. As that goes up, what happens to the dollars? Well, that's going to go up as well, so we would say that it varies directly. The temperature in your house varies how with the amount of time the air conditioning is running. So time the air conditioning is running, if that increases, what happens to the temperature? Well, it's going to get colder, so it decreases. So this varies inversely since one goes up and the other goes down. Next one, the length of the side of the square varies how with the perimeter. Okay, so I always start with the second one. So as the perimeter increases, what happens to the length of the side? Well, that's going to go up as well. Varies directly. And finally, your GPA may vary how with the number of hours of TV you watch. So as the number of hours of TV you watch goes up, I think that your GPA might go down. You might argue that. I suppose you could be watching very educational TV, but if you're spending all your waking hours watching TV, there's a good chance you're not getting schoolwork done, so we think it may go down. Okay. In the next lesson, we're going to do more practice with different ways that you see direct and inverse variation, but this should give you a fairly decent background on defining the two.